Hi, it's Professor Adam. Let's talk about acid-base titrations. Titrations are often used in analytical chemistry for the accurate determination of substance concentration, such as acids, bases, and other species. A volumetric titration requires a reagent of known concentration, a standard solution. This standard solution is then added slowly to the analyte until the reaction is deemed complete. By considering the volume of standard solution added, the concentration of the unknown can be calculated. A titration involves the reaction of an analyte of unknown concentration with a reagent of known concentration. There are three main types of titration: volumetric, where volumes of solution are reacted; gravimetric, where masses are reacted; and coulometric, where an electric current consumes the analyte. A classic titration is that of a strong acid being titrated with a strong base, such as hydrochloric acid being titrated with sodium hydroxide, which has this overall equation. There are four main regions of this plot: the initial pH of the acidic solution, the increasing pH as base is added, the equivalence point, and the pH after the equivalence point. Initially, the pH of the solution is 1, but as more base is added, this starts to increase. Let's determine the pH if 20 milliliters of strong base is added to our solution of 50 milliliters of strong acid. With our balanced equation, we need to calculate the concentration changes using a reaction table. This gives us a new proton concentration of 4.29 times 10 to the minus 2. And a pH value of 1.37, which is higher than the starting pH of 1 due to the consumption of the hydronium ion in the neutralization reaction with hydroxide. Let's look at the next points of interest. The equivalence point, which is the steepest part of the curve. For a monoprotic strong acid-base reaction, the pH will always be 7 at the equivalence point because the solution contains a neutral salt. After the equivalence point, all the strong acid has been consumed and the pH continues to rise. The pH after the equivalence point can be calculated in a similar manner. If 60 milliliters of strong base is added, then the pH is expected to be basic. As before, with our balanced equation and reaction table, we can get the hydroxide concentration. This can be used to calculate the pOH as 2.04, giving the pH as 11.96. Let's check comprehension.